This is Mrs. Hedden. This is a Pendulum Lab pre-lab video. We're going to need the photogate timers. We're going to need the physics stand, both the triangle and of course the metal post with its bolt. We're going to need the washers. We're going to need a pendulum setup and a meter stick. And you're actually going to need two of these guys. I only have one in the picture. This part of the pendulum is called the pendulum bob. Hi, Bob. Hello. And this will all be detailed in the lab procedure you have tomorrow, so you don't need to write that part down. Okay, you're going to put the physics stand together. Remember, first we take the bolt out of the metal piece, and then we put the triangle down, stick the bolt up through it, and then you take that metal piece and screw it in, which you've done before. Then the next bit is you have to attach the pendulum apparatus to it. The pendulum apparatus is going to go in the very top hole. So this wooden part, and you can see right here this little bolt, or it's perhaps clearer over here, that little bolt goes in the top hole of the physics stand. That is not in the procedure, so make sure you get that correctly. And you may end up having to put this wooden peg in the physics stand or in the pendulum apparatus. That split part sticks out so that the very end, the split end, is closest to the outside. Okay, and the reason for that is because you're going to put the string from the pendulum in that little notch. And it's better to have that string closer to this end. If we put it in close here, it causes problems. So try and have it positioned closer to this end. You're going to have some little extra string left over. If you want to loop it around over here and get out of the way, that's nice. And then at the very end of the string, of course, hanging down, we have good old Bob with a couple of washers on him. Now when you put this pendulum apparatus in, we want this vertical line, which is like that for the pendulum, aligned with the 0 degrees right here. And you can see they're not in alignment in the way I did it right there. That means I would have to loosen up this bolt here and then scoot this wooden apparatus over just a little bit better so that the 0 degrees is lined up with the string when it's in its rest position, or the equilibrium line. Next up, you're going to grab the photogate timers. Okay, we only going to need one photogate timer, so we only need one timer. Okay, once you get the one timer out, the next thing you're going to do is take one of those bolts and you're going to put it in the third position. 1, 2, 3. So you can't see those holes here in the view picture I've got, but this bolt is the third hole up from the bottom. Okay, and you're going to put that bolt in, and then you look at the side of the timer and you can see there's this little opening right here. That little opening corresponds to where the bolt goes in, and so of course you're going to take the photogate timer and put it in sideways onto the physics stand. You have to line up the widest part of the wooden pendulum bob, so I'm kind of drawing it in here, so that this electric eye hits the widest part of the wooden pendulum bob. And that alignment is kind of important. Okay, so here we have, again, this little electric eye, and it's looking right at the widest part of the wooden pendulum bob. Really, really important that alignment is done correctly. Next thing I have to do is measure the string length of my pendulum bob. So it's nice to be consistent. The easiest way to be consistent is to go from the top of the wooden part of bob. So I'm measuring from here, and then I'm going to measure my string up to the bottom of this wooden dowel. And so, the way I've got it set up here, it's about 71 centimeters. And we're going to measure it in centimeters. We're not going to have to worry about converting it to meters. So you want to really be consistent with how you measure it. And the best way to be consistent, again, is going back to this picture. We've got the meter stick lined up with the top of the wooden part. And then over here, we're looking at the bottom of this round wooden dowel. And that's how we're going to measure our string length. And we only measure the string length after we adjust the bob so that it's in the perfect position in order to set off that photogate timer. And there's the photogate timer. So we're going to take the electronic part of the photogate timer and, of course, plug it in. And once you plug it in, you should get the CPO here. And notice the little green light is on interval, and we've got CPO, or you might have a 0 showing up. Okay. You want to go ahead and press it so that the A light is on, so the green A light is on, and the period is showing up. So you want to press it so green A light is on and the period is showing up. This is not in the procedure, so make sure that you're writing this down. Okay, this should be green A light, this should be on period, because that's what we're going to be measuring. We're going to be measuring the period of the pendulum. Okay, and then of course you're going to use the telephone wire to hook it up to the photogate that you've got mounted on the third position from the bottom. And there we've got it all lined up. We've got then that phone cord going into the A slot. There's 2 slots in the back of here. We don't want it going into B, we want it going into A, because we only are measuring one time here. So photogate into A slot, A light on, and period. Then you're going to pull it back, and you're going to try and line up this string. In fact, you're not going to try, you are going to line the string up with certain degrees. So this string right now is lined up with 25, 25, 26, 27. It's at the 28 degree mark. Okay, unfortunately, we're not going to be doing 28. We're going to be lining up with the 30 degree mark, or the 20 degree mark, or the 10 degree mark. And that part will be in the lab, but you want that string exactly on the 30 degree mark, exactly on the 10 degree mark, or sorry, the 20 degree mark, and exactly on the 10 degree mark. And getting that to be exact is really kind of tough. It's going to require a little bit of help from your partner, so you're both going to have to look on and make sure you get it on the right spot. Okay, here you see me swinging a pendulum, and I start it, and it goes back and forth, and if we look down at the timer, we can see what's going on. So it's going to go again, and again, you just want to make sure you get it about the 3rd swing, and now we've got the half period, because that's what's recording, half of the period, the time for it to go through it once. This lab is kind of interesting because you're going to actually be running 3 separate variables. You're going to first change the mass, and this will be outlined in the lab procedure. You're going to keep the string length constant and the amplitude release point constant, and that'll be like 20 degrees all the way through. And the string length will be whatever it is when it's in the 3rd position. You're going to vary the number of washers, and then that pendulum timer only gets the half period. So you're going to write down the half period, and you're going to use all 4 digits in that half period. And then you're going to calculate the full period, which of course is just 2 times the half period. Then you're going to increase the number of washers, find this again. Increase the number of washers, find this again. And then you're going to go back to your original number of washers. So you're going to go back to the original number of washers, just to say washers. And you're still going to be releasing from 20 degrees. And then you're going to change then the amplitude. So you're going to do 10 degrees, 20 degrees, and 30 degrees. And then you're going to go back to the name. You still got the same number of washers. You're still going to be releasing 20 degrees, and you're going to change the string length, and you're going to have a long string length, a middle string length, and a short string length. So you'll have 3 separate variables. Each variable is going to have 3 trials. In the end, you're going to end up making graphs, and you're going to print out 6 graphs. And again, this will be on the procedure, so you don't have to take notes on it right now. 1 graph from each variable, so 1 graph from mass, 1 graph from amplitude, 1 graph from string length. You're just going to have it auto-scaled, except you're going to need to auto-scale larger, and I'll show you that in a minute. And then 1 graph from each of those variables, 1 for the mass, 1 for the amplitude, and 1 for the string length. You're going to auto-scale from 0. Again, except you'll need to auto-scale larger, and I'll show you that later. On all 6 of these separate graphs, you're going to type the percent difference between the first trial period and the third trial period. And again, I'm going to show that to you in a minute, what it's going to look like. I ended up putting them all in the same graphical analysis program, but that's up to you. But you're going to go ahead and make sure you do that. The period for the mass is really just the number of washers. So we're going to have on the x-axis the number of washers. And then you can see here, if I go down to Analyze, I've got Auto Scale, and I've got two options for Auto Scale. I've got just plain Auto Scale, and I've got Auto Scale from 0. And you're going to do both of them. You're going to hit Auto Scale, and you're going to hit Auto Scale from 0. Two separate prints of the same graph, just scaled differently. But in addition, the Auto Scale, either one of those, Auto Scale from 0 and Auto Scale, is going to have the line way up at the top, and it's going to be really hard to read. So what you're going to do is down here in that dialog box under Graph Options where it says Scaling, even though you've got Auto Scaled, you want it to Auto Scale larger. And you want the top number to be equal to one digit past what your full period is. So say your full period was 0.832. We want it to be 0.9. Okay, we want to go 0.9 at the top. If your full period was, say, your full scale period was 1.23, we would want it to say 1.3 at the top. And then the hard thing is you're going to type into a dialog box the percent difference. You're going to take the absolute value of the final period minus the initial period. You're going to divide it by the final period, multiply by 100, and you're going to type in the formula into that thing. And you're going to type in the numbers, and then you're going to type in your percent difference. Okay, and then you're going to print it out. So here we can see where my line is. This one is auto-scaled from 0. I've got in my percent difference. I'm just printing out the data table also. It's no big deal because we only have 3 pieces of data for each table, so it's not a big deal. And that's the end of the pre-lab video. Thank you very much for your time.